Today we are going to look at determining the equation of a curve. We have seen this in National 5, where we were finding the equation of a parabola. Given the roots and at least one other point lying on the curve, we can establish its equation using a similar process to finding the equation of a parabola. In this example here, a, b and c are our roots, which will give our brackets x minus a, x minus b and x minus c. However, the function may also have a constant k which we need to find, and you can see we have one other point given to us, which is point D, which will help us do this. Key steps. Step 1, insert the roots of the function into the general form f(x) equals k multiplied by x minus a multiplied by x minus b multiplied by x minus c. Step 2, substitute another point, xy, into the function and rearrange to get k. And finally, state your final answer with roots and k inserted into the function. Example 1. Find the equation of f(x) shown below. The first step, we need to insert the roots. So if we have a root x equals -1, this will give us a bracket of x plus 1. A root of x equals 3 is a bracket of x minus 3. And a root x equals 4 is a bracket of x minus 4. We may have a constant k, and as you can see when given one other point on the graph, the other point is 0, 12, and we must sub this in. So x is 0 when y is 12. So 12 equals k times 0 plus 1 times 0 minus 3 times 0 minus 4. Simplifying our brackets in the right hand side, this gives k times 1 times -3 times -4. 12 is equal to 12k, so k has a value of 1. The equation of f(x) is x plus 1 times x minus 3 times x minus 4. Example 2. Find the equation of f(x) shown below. Here we have one root shown, which is x equals 3. As the root does not go through the x-axis, but merely touches it and comes away again, this is a repeated root. Therefore, the function can be written as k multiplied by x minus 3 times x minus 3. We must then use the point 0 minus 9 to find our value of k. Substituting 0 for x and -9 for y, we get -9 equals k, 0 minus 3, 0 minus 3. -9 is therefore equal to k multiplied by -3 multiplied by -3. -9 is equal to 9k, therefore k is -1, which you should be expecting because we have a parabola which has a maximum turning point, which must have a negative x squared at the start. Therefore, the function's equation is -1 times x minus 3 times x minus 3. Now try these examples on your own. Please pause the video. The answers for a, y equals 2x cubed plus 16x squared plus 18x minus 36 when expanded out, and b, f(x) equals 3x cubed minus 3x squared minus 12x plus 12 when fully expanded. If you want to try some more questions, please turn to page 141, exercise 7H, and try questions 1 to 15. So what have we learned today? We have looked at determining the equation of a curve. We must follow the key steps, inserting the roots of the function into the general form fx equals k x minus a, x minus b, x minus c. We must then substitute another point into the function so that we can obtain a value for k, and we must then state our final answer with all roots and k inserted.